from Group 5 here to explain you all about our project that is quantum computing. But before starting to explain you about quantum computing, I would like to tell you about its history and from where the idea came from and why quantum computing is needed so that you can understand it better. Now, I will start with the introduction of quantum computing. Introduction. Quantum computing is the area of study focused on developing computer technology based on principle of quantum mechanics. The power of quantum computer is that it is based on logic that is not limited merely to on or off, true or false scenario. Quantum computing uses qubit. It can represent a 0, a 1 and both, which is known as superposition. It uses phenomena such as quantum tunneling and quantum entanglement to solve more complex calculations. From optimization problem to stimulation, machine learning and weather forecasting all will be possible with accurate outcome with this technology. So, where did this idea came from? Quantum physics, the study of fundamental law of our environment. See Max Planck and Albert Einstein. Quantum computing. The idea, originally proposed by Richard Feynman in 1980s, that we can leverage quantum properties for computation and solve problems unsolvable by computing. Now, history about important discovery that play an important role in quantum computing. First, in 1918, Max Planck energy quantum. In 1921, Einstein discovery of photon. In 1980, the idea of quantum computation. In 1994, Shor's algorithm was able to factorize large integers in polynomial time using quantum approach. In 1996, Clovers came up with an algorithm to search a name in unsorted database. Then the question arises, why do we need quantum computing? We can use classical computer as well. Then why quantum computing? Here are some reasons why quantum computing is needed. There are many kinds of numerical problems like algorithms cannot be solved using digital computers. Then many of us are thinking that why quantum computers are not used instead of classical computers for daily work. Here is the reason. It requires faster technology and smaller calculating devices which are under developing. Now, I will tell you about what is quantum computing. A quantum computer is a machine that performs calculation based on law of quantum mechanics, which is the behavior of particle at the subatomic level. A quantum is a small possible discrete unit of any physical property. Quantum computation depends on principle of quantum theory. Now, many of you are curious about how quantum computer works. You can easily understand by the example I am going to give you. Suppose in a 3-byte register of a classical computer, one of the 8 number can be stored, but in quantum register, all 8 numbers can be stored in one register at the same time and operated on simultaneously. Then the question arises why quantum theory is needed in computing. Classical, or we can say Newtonian, mechanics deals with microscopic system, while quantum mechanics deals with microscopic system at atomic and subatomic level. Computer components are becoming smaller and smaller, from mechanical computer to vacuum tubes to transistors then to ICs that classical theory fails to explain. The quantum theory become essential. Then, what is qubit? A qubit is a quantum byte, as a byte is the basic unit of information in a classical computer. A qubit is the basic unit of information in the quantum computer. A physical implementation of qubit could use the two energy level of an atom, an excited representation 1 and ground state representation 0. Now, there are various difference between the digital computer and quantum computer. Some are. In digital computers, transistors were used, while in quantum computers, quantum mechanical phenomena are used. In digital computers, and information is stored in the form of bits, while in quantum computer, information is stored in the form of qubits. In digital computers, silicon chips are used, while in quantum computer, atoms are used. It is comparatively slower in speed while quantum computers are faster in speed. Now, I will tell you about what are the advantages and disadvantages of quantum computer. Now, we will go with I will tell you about what are the advantages of quantum computer. Faster computation, best for data stimulation, medicine creation, Google search, high privacy, used in radar making. Quantum computing is also used in making radar missiles, used in artificial intelligence, machine learning. Quantum computing is applied nicely by using machine learning techniques. Now, disadvantages of quantum computers. Algorithm creation. For every type of computation, it needs to write a new algorithm. The second, the lower temperature needed. As the processing in this computer is done very deeply, so it need a temperature of negative 460 Fahrenheit, not open for public. Due to high range price, they are not available for public uses. Internet security. Whole internet security breaks. This is due to the fact that this computer can decrypt all the codes on the internet. Now, what are the important properties of what are the important quantum properties that are used in quantum computers? The first one, decoherence. It is the biggest problem. It is stated that if a coherent or superposed state interact with the environment, it falls into a classical state without superposition. So, quantum computer to work with superposed state, it has to be completely isolated from the rest of the universe. Second, entanglement. It is the most important property in quantum information. It is stated that two or more particles can be linked, and if linked, can be changed properties of particles, changing the linked one. Two particles can be linked and change each other without interaction. Third, uncertainty principle. Quantum systems are so small. It is important to measure all properties of a quantum system without disturbing it. As a result, there is no way of accurately predicting all the properties of a particle in a quantum system. Now, what is the future of quantum computing? First, powerful new resource for computation. Second, complementary to classical computer. Third, accessible via the cloud. Fourth, emergency of quantum software ecosystem. Developer tools, optimize algorithm application. Now conclusion and scope? What are the conclusion and scope? Various researchers are actively looking for new algorithm and communication protocol to exploit the property of quantum system. D-Wave System, a Canadian company that claimed to have developed a 28 qubit quantum computer. Through there have been criticism of their claim. In 2007, they demonstrate the use of 16 qubit computer to solve such problems as pattern matching, sitting arrangement, and a Sudoku puzzle. It is unlikely that quantum computers will entirely replace classical computer. Their advantages over classical computer is significant only in a specific application area. It is most likely that future computer will instead be some sort of hybrid containing components from both type of computer. That's all. Thank you.